Hello everyone, in this video we'll talk about our senior project. Our senior project name is the use of attention mechanism in time series image analysis. Members Shotika Phanakit Reung and Yorin Sarathikit Anand. This project will approved by Project Advisor Assistant Professor Thirasit Kasem, Project Committee Assistant Professor Kanchanapan Suvichai, and Exam Committee Assistant Professor Somying Thanimit. In this presentation, we cover these topics. First, let's talk about cost of this project. Some technical challenges when classify or detect flood area from the image. Clouds are major problems in the classification or detection of flood or standing water using satellite data. Because cloud shadows and flood water have similar spectral characteristics, the traditional means of classification based on spectral properties may fail to determine them from each other accurately. Next, about our project. The objective of this project will find the outcome or effect of the attention layer execute on input datasets which are time series image datasets, array of TIFF image that acquired from Google Earth Engine, and contents of clouds and cloud shadows. If the attention layer can help machine learning to detect or preventing cloud elements, they will be easier to classify the flood area to ensure the real event with a better accuracy of gene values. And what is attention layer? The attention mechanism or attention layer in deep learning is based on this concept of directing your focus and pay greater attention to certain factors when processing the data. In broad terms, attention is one component of network architecture and is in charge of managing and quantifying the interdependence between input and output elements are general attention. Within the input elements are self-attention. And what about classification? Classification is a process of categorizing a given set of data into classes. It can be performed on both structured or unstructured data. The classes are often referred to as a target, label, or categories. Classification is a type of supervised learning. Even the targets are also provided with the input data. The classification model predicts or draws a conclusion to the input data given for training. It will predict the class or category for the data. Next, what about materials that we use? First, we use shapefiles or .csv file that we got from Bank of Thailand or BOT that store the observation recorded of flood events on each cultivated area of Phitsanulok and Roi Et district, constantly recorded since 2017 to 2019. Second, we use QGIS program. QGIS adds a geographic information system GIS software, allowing users to analyze and edit spatial information. QGIS supports shapefiles coverage, personal geodatabase, DSF, MapInfo, PortGIS, and other formats. Third, we use Google Earth Engine dataset. Google Earth Engine combines a multi-petabyte catalog of satellite imagery and geospatial datasets, providing a ready-to-use datasets. Another materials that we use are Google Colab. Colability, or Colab for short, is a product from Google Research. Colab allows anybody to write and execute arbitrary Python code through the browser and is especially well suited to machine learning, data analysis, and education. Last, we use a computer PC or notebook to compile the code and run the process of data. Next, our methods of these projects. First, read and analyze the shapefiles. Get the shapefiles of the crop insurance data of two districts, Phitsanulok and Roi Et, from BOT or Bank of Thailand, and open it in QGIS program. Before loading the dataset, we focus only recorded in 2019, so we're filtering for months that have a disaster flooding and loss ratio value greater than 1, following to this picture. Next, we acquire the data from Google Earth Engine or GEE. After opening the shapefile in QGIS, we choose two coordinates of the polygon area and set the step of 0.03. Run the command to Google Earth Engine for exporting Sentinel-2 image. Data to collect time series of image in 3 months are contained pre-month of flood, month that is flood, and post-month of flood. Next, we load the image with 5 bands, which are B2, B3, B4, B8, B8A, using this pattern code. To acquire that, and we're using Google Colab to compile this code, and we'll save the TIFF files automatically to our Google Drive. And this is some series image that we got from Google Earth Engine.
Next, generate GraphTube. GraphTube is a term used in various fields to refer to information provided by direct observation as opposed to information provided by inference. We use time series image that acquired from Google Earth Engine and .csv file of Pisanulog plot data to generate the GraphTube in form of .csv file to labeling the data to use in classification process. 0 as a non-flooding area and 1 is flooding area. Also, including burnout data. Burnout is able to reduce the error of estimating the GraphTube fatigue index gradient on average compare. At the picture on the right hand, the dark color is assigned as non-flood, and the light color, white color, or yellow color as a flood. The value at the center is a flood ratio per one image. Prepare dataset to change. We convert TIFF file as array with 2 periods of time and collect all of the band to b.npy file to put in the model. After we got 2 periods of time, we resize the picture image to be 224 by 224 before going to change by interpolation method. This is a sample of all dataset. We have input the TIFF file as you can see. The actual TIFF file with RGB will be the result at the left hand, and also at the right hand of the time series inlet band, we have flood and non-flood, including with the some cloud or white area. Model classification with attention layer. We have used efficient net unit and input shape as 224 by 224 with 3 band, and we create attention layer inside. This is what model classification look like. The output will be one dimension, and we have input the T periods of time series in the model. And for the attention layer is inside the model classification. The same method as the classification model, but the output will have T dimension with T bands or output in image. To change the model, we use turn on back function to change the model. This function is for updating a pre-trained model on a single new batch of sample with the limitation of dataset to change the model. The turn on back function will execute a gradient update on one particular batch of training data. It then performs back propagation, and after that, the function updates the model parameter. However, in turn on back function, we are not required to specify the batch size, but for this model, we set batch size at 16 and epoch at 100. We use the optimizer is a dumb and lost binary cost entropy. The input of the convolutional network is a single clock 224 by 224 image. This is the result of model classification. The left hand is model accuracy graph. You can see the add and the loss at blue line and orange line. No overfit or underfit, or the model can be changed more to decrease fraud and also increase accuracy too. At the right hand graph, the predict value as you can see on the blue line, predict value between 0 to 1, and also at the same time, we have been out the orient line as our output mean. The output mean is average of each image array. The result of model predict and output mean is look likely to tend in the same way. After we got the result of model classification, we have to look inside of that model to see what attention layer mechanism do. So we bin out the output of attention layer and get the output in T channel with T period of time like this. Let's zoom in a little bit on a result. The pink highlight area is on same count area as right-hand image showing dark blue color. Also, the white highlight area is on the same shadow of crown area as right-hand image showing light blue or maybe green color. And the rest area is yellow for can area or red crown area. After that, we scatter plot between output image and input image and choose the average of each image to plot on this graph and observe the value for each pixel from array of an image. After that, we build correlation graph by input value to be green line with output blue line to find how much is related with each other. And for this example, is 79% correlate. Summary. We have changed the classification model in order to focus on the effect of attention layer, what is behaved with the flat image that cover with some cloud, because of the problem that we used to face with in our count. Major problem of the classification or detection of cloud and some area of standing water or shadow of the cloud. The result that we observe is image output shown in yellow, blue, and a little bit of green. The area of the blue color is delayed with the cloud area from the right-hand side image or input image. And the left area that is not blue color is not on the cloud area too. The shadow of cloud shows it light blue or green color. Also compare from the scatter plot graph, the value of array image and output image show likely to inverse with each other, blue and orange line. After we invert input graph to find its correlation, the result is related with each other in likely the same way, with high percentage than 70% for all datasets. After all, we can conclude that the attention layer mechanism can help model to detect or specify the cloud area of the image.
For the reflections of this project. From this project, our group have learned many things such as coding, the attention mechanism, the multi-bands usage, how to differentiate create model, and recall that we use in analysis, the limit of using Google Colab, and the way to access the damage of the flood from many edges. Thank you for watching.